Okay, so why are CAD files, oh, I'm sorry, go ahead.
Well, when you were saying happening all around us, yesterday I had a new crown, tooth. And I haven't had one for a couple of years, so I don't know who else here has had a 3D printed crown, but basically that was it. It was a 2-hour appointment. And they took photo, you know, there wasn't any of that mastic stuff. They just shot, you could feel them like shooting the image, and it was very three-dimensional color on the screen. And then he pulled points down to fill in, you could tell hot spots where it was too thin. So he took a picture of the tooth, and then they ground it down to that lump that they stick the crown on. And then they took a picture of that, and then the two images were put together, and then it was sent to the machine, and I got a very nice looking, way in the back, but it was 2 hours.
Right.
It
So
was cool.
that's not possible, going to the dentist and getting,
Yeah,
you know,
it was
that
the
done
same
in that kind of
price as,
sitting
you know,
is not
waiting
possible
and-
without CAD technology.
Yeah.
So,
Three college professors at the U of M took my work at Jostens under their protection and developed a bunch of dental applications and dental systems, and that may be where that came from
Right.
a long time ago now.
okay, so why are CAD files important? The main thing is communication. This has nothing to do with CAD, but I like it. If you can't read it, it says, and that's why we lift on 3, in case you know. It's how everybody in the design life cycle communicates. This transcends languages, cultures, industries, everything. So if you're working with somebody overseas on manufacturing, you don't have to speak the same language as them, as long as you can provide a very detailed CAD file. That's what they're going to understand more than you trying to explain. Can you imagine trying to talk to somebody in China that doesn't hardly know English or doesn't know English at all, trying to explain your napkin sketch to them, and imagining what you would get back. CAD files are the only way to clearly communicate your design to your manufacturers and other people on your team. Why else are they important? Documentation. Documenting iterations of your design help keep track of what worked and, more importantly, what didn't work. If something failed, don't just erase it and start over again. Document what failed about it, move on to the next iteration, and that way when you're looking at making more changes, you can look back and see what you've done, what hasn't worked, what has worked, and keep refining that design. Revision control. I can't stress this enough. And this happens a lot in our business where people send in the same file name every single time. And it's different every single time, but the file name is the same. That is very dangerous because we give a quote based on a certain file name. It might be the right one, it might be the wrong one. You don't know until you get the part and realize it's the wrong one. So adopt some sort of revision control in all your documents, whether they're paper documents, whether they're CAD files or anything. And it can be simple as adding a date into the file name. So it's, you know, bracket number 2 and then 021616. You know, just something like that that gets changed every time you change something about the file. You save this off as a new file, make your changes, change the file name, now you've got revision control. That's in its basic form. So just please, for the sake of all things, just maintain revisions. Patent and copyright art. This is something that got passed around between the board members here this week. This is the original patent art for roll of toilet paper. I never knew that existed.
1891.
Yep, 1891. So I think it might have expired by now. So this is something new. You want to touch on this, John?
Sure. The patent office resisted these beautiful CAD drawings in the beginning until they realized, whoa, that's a far better drawing than a patent illustrator could make. You know what a patent illustrator, I think that's a dead profession now. Patent illustrators drew things with ink and pen, and they were beautiful artwork pieces, but they didn't communicate your claims very well quite often. And that's what's really important. So the patent office now prefers that you send, when you apply for a patent, CAD drawings. And you can, from a CAD system such as the ones we've been talking about, you can rotate and shoot a picture at any angle, any orientation, and get some wonderful good communication CAD drawings as part of your patent. Now also is true with trademark, by the way. Trademark, especially if you've got trademark art. CAD art for submitting a trademark is desirable over manual art.
Does the patent office allow downloads of the CAD file when you search for a patent? Look at someone's artwork, or can you only see the pictures?
No, it's just a two-dimensional image that's actually on the patent application. So you're using the CAD data to create those images.
Oh,
It used to
okay.
be hand-drawn.
So you don't send the CAD drawing to the patent office, you just send the picture that you printed from it?
Exactly.
Well, you can send them the JPG file. They like JPG files. I've done several of those. I have about just short of 40 patents right now, so done quite a few.
This got cut off, but basically this was the paragraph describing what your patent art needs to include, and exploded views and blown up partial views of specific portions of the invention. That's very easy in CAD. Once you've got, I think this next one. Okay, so this is an exploded view of this assembly. So this is what CAD is for. You build everything together, you make sure it fits, but then you can explode that view just to check, just to have a better explanation. So that's what they're talking about. Instead of recreating the wheel by hand, just utilizing the art or the CAD file you already have to create it.
And you have not made this machine yet. You haven't produced it. It's strictly an idea,
Right.
but completely designed. So what is a CAD drawing? Well, there's a CAD drawing for every part in that exploded view.
Yeah.
So
Yeah,
it's a
everything.
library. We called it a CAD database.
Yeah. CAD library, CAD database. You can call it all. So, with all that said, go ahead, sir.
What did it say at the end of the last prior slide about the drawings facing together?
Oh.
Together? Oh, same.
Facing the same direction on the page.
Oh.
That's all.
By the way, that's the way you're supposed to install a toilet paper roll.
This is documented proof, and anything other than this is law. Okay, so with all that said, I hope I've conveyed to you what CAD files, the differences between, it's not just a catch-all term. We hear that a lot, that, hey, I have a CAD file. Well, let's take a look at it first to see what kind of CAD file you have, what condition it's in. There's a lot of different things that can go wrong with CAD files. And that's why it's real important to get somebody on your team earlier rather than later if you plan on going to production. If you have the skill set to do this yourself, great. More power to you. But more inventors don't have that skill set, and you're going to spin your wheels a lot. So try as hard as you can to get somebody on your team as early as you can to start generating true CAD files for what you actually need. Yes, sir.
I might also mention that a lot of times you might think you've seen everything, and then once you put it into the CAD file, there will be things that come up that, oh, this doesn't even fit.
Exactly.
Interferences.
Yeah.
Yeah.
We do that even, we do some design work for our customers. We did these little stoves. They're going to be cast, like John was saying. We did all the CAD work and everything, and I asked my designer to put it together in assembly and make sure the doors actually work. He found some clearance issues, and we're just talking about a little metal stove. So he made a few tweaks, and everything worked in CAD. So now you know that it's probably going to work in real life, depending on tolerances and a lot of other stuff. But it's a real good way to check things. So by getting somebody involved early, you're going to save a lot of time. You're going to save a lot of frustration, and most importantly, you're going to end up saving money over the long run because you have what you need early on. We tell inventors a lot. If you're going to fail early. You don't spend a ton of money getting to the point where it just doesn't work out. So CAD files, sometimes, like John was saying, you can figure out that something is either going to work or not work before you've done anything in the physical world at all. But if you're just going in and playing around and kind of thinking about stuff and not doing it correctly, you're going to get incorrect information, just like any other software.
We use SolidWorks quite a bit, but I think the other systems have the same capability. You design all of the parts individually, and then you assemble them, and then you operate it.
Right.
So I'm building a machine right now, 6-axis CNC machine down in Rochester to make keys. on patents that I got 15 years ago, so they're getting right. And we're doing it all with SolidWorks, and the investors want to see this machine operate in simulation before they put the big money in, because they want to make sure we understand that we can't collide with our own frame when we're changing positions. You have to make every kind of key there is, because it's for locksmiths, it's the security keys, everything. And so it's a very complicated machine, but I guarantee you it's going to work first time because we're doing it all with full animation analysis.
I'm just trying to bring something up here. Onshape is very capable of handling this. So when you're doing assemblies, it's important to give the parts constraints, real world constraints, like a bearing is going to turn around a shaft, a lever is going to work around something. A shaft is going to move in and out of a hole. Let's see if this works. Yep. So here you can get in here, and then some programs will actually stop when they get to a certain point where it collides, and that's what we did with a small model in SolidWorks. When it gets to a point where it collides, it stops and it turns to two features red, or
Yeah, that's what I was going to say. Color change is
Exactly.
the first indication that you just made a crash.
Right. All this before you spend any money on a physical product. Yes, sir.
There's another application, like for example with your hydraulic cylinder that you just showed there, that can take a great deal of guesswork out of it, which is the computerized analysis.
Absolutely. So he's asking talking about computer analysis. The really expensive CAD systems can actually calculate how air is going to flow, how hydraulics are going to flow, how different pressures and everything are going to affect things. You put a motor to this shaft, what actually happens on the other end? There's a lot of simulation to go on, more than just grabbing it and moving it around. So that's, again, where you want to bring in the professionals, because they know how to set that up right, so the data you're getting out of it is very accurate. And along with that, even stress on the part. Again, the very expensive systems can actually put a load on the part, and you can see if it's going to break at a certain load. I guarantee John has done that more than a few times with these parts he passed around here, just to make sure that, hey, this wall is strong enough to withstand this much pressure. Now we build it in the real world, we test it, validate what we should already know from the CAD system. So that's all very good, very important part of development projects. Okay, so we have a real world example here. Again, these drawings didn't show up very well, but John worked on a product called the Revinator. I'm going to let him describe it to you and tell you, describe to you how many different processes, how many different CAD files went into these.
These are Revinators. A Revinator is an electronic ignition for a vintage Chrysler muscle car. And my client wanted to have a ability to limit the high speed, because last year 4 1969 Dodge Chargers, fully restored, sold at the Barrett-Jackson auction in Phoenix for $2.2 million a piece. That's if it's all matching serial numbers. If you pull a rod and have to replace the engine block, you can replace the block for $500, but it will not have the same serial number, and you can't, by federal law, modify the serial number. You just lost $500,000 in value on that vehicle because you don't have the original serial number, which is recorded on the original title. And the differential number, case number, and the transmission case. There's only 3 parts in that car that have serial numbers. Anyway, the Revinator has a button on the front here, and 7 little LEDs. And you can light the LED that represents the RPMs that you want this engine to stop at, its ceiling, its governor, its maximum speed, to keep from accidentally blowing it up. And all you got to do to blow it up is put your foot in the carpet with the accelerator pedal underneath of it and try to shift into 3rd gear and miss 3rd gear. For that instant, the engine goes whee, because it's not in gear, and boom, and you see the hood go fly up, and you've got parts all over the place. So that's something to be avoided. So the Revinator,
That's an understatement, John.
the Revinator is based on a little integrated circuit here. It's called a PSOC, and I've got a naked one here so I can pass around and you can see what it looks like. A PSOC is a programmable system on a chip. What's it take to design an electronic product? Well, first of all, there ain't no such thing. It's electromechanical. We have to design the case. In this case, I had to match Chrysler's plug because we're going to use Chrysler's our harness, and we can't buy the plug from Chrysler. They don't want us in the business even. So this is the drawing for the connector with all the dimensions required to make this little plastic mold for this connector, which we made over in Somerset, Wisconsin, and we make them by the thousands. The other drawing is the CAD drawing of the case, which is a stamping made out of steel, and that's before painting and everything. This one is potted, meaning it's got a plastic material poured in the back, which makes it steam cleaner proof, weatherproof. Under the hood, it's got to be very, very rugged. This one's naked. It hasn't had the stuff poured in yet because it had a flaw, which I fixed the other night, so it's ready for potting now. There's another little wire coming out the back here, not labeled. That's to drive your tachometer. If you have a Chrysler Mopar tachometer in the dash that still works, then you can drive it with this wire and the needle won't go flitter, 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 flitter. It'll be nice and smooth because I drive it with my PSOC. The PSOC is a microprocessor system and two programmable electronic systems. One is a digital electronic programmable array. It's called an FPGA, Field Programmable Gate Array. I'm full of acronyms, by the way, so if I don't define one of them, raise your hand. I know the answers. And this other one is an analog array, which doesn't have an acronym in the industry because they're brand new at inventing programmable analog arrays. So the schematic for this thing is 2/3 or maybe 3/4 and a file that you load into this chip, and the rest of it is what you can see looking at the printed circuit board. By far, there's more electronics inside of that chip than there is in this fairly poorly, low-populated printed circuit board. And if you put this thing in your Mopar, and that's basically 10 years, 1963 to 1973, you'll get 45 more horsepower. So there is a blog going around now from last year because we've had this is our 3rd year. And the blog was created by our customers, and it says, if you campaign a vintage Mopar on the weekend and you don't have a Revinator, you're going to be beat by somebody who does. So the racing community that we didn't even study for the market analysis is buying these things as fast as they can get them. So here's 2 of them. This one doesn't work, by the way. That's why I have it. They won't let me have things that work. I did fix this the other day, so this one does work, but it's not potted. So I want them back.
Did you get the specs for that Chrysler compatible plug from Chrysler, or did you reverse engineer it?
Reverse engineered it.
So you had to measure it and all that?
Yep.
Trial and error also.
Yep. And the pins, you can't see it very well here, but the pins are all at different angles. So there you see, there's an angle, 60 degrees. And it's not the full. Chrysler made it with this pin over here too. They had another pin. Then they abandoned it some way along the way, and the connectors don't have the pin in them, so I didn't want the hole there, so I molded it without that one. But we could add it if we ever needed to. Now this is an example of electromechanical product. A lot of CAD in the mechanical, as you have already seen with everything else, but a lot more CAD in the electronic, which you don't see. You don't realize it. There's a CAD system from, in this case, it's Cypress Semiconductor. Cypress has up until recently been using the old control data fab over next to the airport to make these chips. Then they send them to Malaysia and have them put in a package and then send them back here so I can put them in the product. I have a contract manufacturer down in Austin manufacturing this right now. And my client is in Belle Plaine. They're called RT Garage. What's RT stand for? Anybody know? Well, we had a Lutheran pastor put one of these cars in his church service about a year ago, and he drove it out on the stage. It's one of these big auditorium churches, and he rolled the sunroof back and he stood up with his mic headset and he says, "Welcome to this morning service. This is a muscle car. And he said, today's service is going to be about masculinity. And he said, see that RT down there on the side of the car? Yeah. Well, it stands for race tuned in Mopar. He said, they think they know what it stands for, but I know better. It stands for raging testosterone. He's pretty well on the money with that. So it's been a fun project, and it's been neat to be able to make something that beats the other guys, the competition. And it's all because of very clever engineering inside of that chip that you can't see. It's totally protected. You can't get at it, so I don't have to worry about you reverse engineering my design. Yes, sir.
John, just reduce this down to where we are. When you designed your plug, and then you created your plug, did you 3D print it? Did you injection mold it from your CAD, or how did you go through that process?
I was confident enough of my dimensions from the Chrysler product that we went straight to a mold. And I don't even know what Chrysler molded it out of. I molded out of Delrin, which is a newer resin, which is very, very sturdy resin. And it's been fine. We've never had any chance to go, any reason to go back. If I did have a concern about it, yes, I might have 3D printed it today. We have the kids in the robot team 3D print parts out of plastics that can't handle the stress. And they build the robot and they go out and test it and bang, it flies apart, it breaks. So they haven't learned yet that you can't just make the part out of anything. You've got to understand stress and strength of materials and those kinds of things. But what they are learning now is I show them how we can go send that file over to Bialka and get back a stainless steel one. If we want to spend a little money. By the way, that housing in stainless steel cost me $600, one piece, but 3 days. And now if we make a mold, well, when we make the mold to make the wax part in production, we know 100% that it's going to work. It's already fully tested all the way through it.
What's your part price going to be when you get to that mold?
What's that?
What's the part price going to be when you get to the mold?
Oh, once we get to the mold, the part price drops. We're going to be making more than one at a time too, to about $1.27. So
that's a good point. When you're prototyping, when you're early on, you're going to be spending more per part because you don't have the volume to justify, the lower prices. So be ready for that. But once you've proven it out and you're confident, I wouldn't recommend anybody just reverse engineering a plug and going straight to a mold. He's about the only person that can do that. So test it out. Make sure it works. You're going to pay more per part, but it's going to save you a ton of money.
yeah, the mold was about $5,000.
Yeah.
So that was a risk. But I was very confident that it was going to be fine. This is how we test them, by the way. This is a Revinator because you can see the button and the lights, and that's the factory ignition. By the way, we had to put a big transistor on the front here to make it look like it was a factory ignition. The collectors are anal. And if it looks aftermarket under the hood, it destroys value in the car. So they will not put it on the car no matter what it does. 45 horsepower be damned. But as you can see, it looks very much just like the Chrysler product. And Chrysler made them with a blue insulator, and they made them with a darker blue heatsink, and they made them gold also. So I decided I'm not going to make all of those. I'm just going to make the gold one. Chrysler makes a black one. We make a black one. Chrysler makes a chrome one. We don't make a chrome one. The chrome one from Chrysler was a dog, and that reputation would transfer immediately. So we decided let's not make the chrome one. There wasn't any difference in them. It's just what the finish was.
Is that transistor functional or just for looks?
It started out to be just an empty can because all it needed to be was just for looks, and it cost me $2 to get an empty can, and I could buy a power transistor for $1.50.
But still, it's not functional though, right?
No, it drives the tachometer.
Oh.
That's how I get that tachometer drive. I decided, well, if I'm going to have to use one, I'm going to make it do something. I'm not going to put it up there just fake. No, that's how that happens. But it only is there because Chrysler had a great big old RCA transistor right there. That was the points. That That's what made the spark happen. Our part that makes that's the right part right here is what makes the spark happen. It's embedded inside the system. And it's got to be cooled. So I cool it with a spring on the backside to the case. And you don't see that without taking it further apart. That was kind of unique. Put a metal spring in there to conduct the heat out of the chip. There's a hole through the printed circuit board underneath of it, so I can get right up on against it with a spring.
Now, John, this was somebody that had an invention that came to you for design help, correct?
They came to me because they wanted to see could you make a Chrysler ignition box that looked like Chrysler's and also have this rev limiting function.
Right.
And I said, okay, yeah, I can do that. How about high performance? How would you like it to be high performance? Will it cost us anything? And I said, no. I lied. It should be just the cost of parts, or the choice of parts. But what it turned out to be 3 years ago was when we started making 45 more horsepower on the dynamometers, people didn't believe it. So we had to start paying for certified dyno testing in order to validate that, yeah, we do make 45 more horsepower. And that cost us for a little bit. But pretty soon, the even bigger dyno companies say, can we test that? We'll test it for free. We don't believe it. And so we started sending them out to certified dyno testers all over the country, all over the world actually. We sell, half of these Chrysler automobiles are in Europe. And probably more than half of them are in Germany alone. There's 4 million in the United States, 4 million in Europe, and I don't know how many are in the racing community because we didn't even think about that when we made this. We just were going after those 8 million customers. Now there's probably 3 or 4 million racers that we didn't budget.
Which CAD package did you use for the circuit board layout?
OrCAD.
Okay.
I have OrCAD, I've had it for years. The circuit board layout is simple here, as you can see, but there are some tricks, real important tricks. See this blank space right here that runs around under those parts and down there and around? This foil right here is connected to the coil. When the coil makes a spark, it makes 15,000 volts. And about 800 of those volts make it back down the wire through that pin into our box. And if it's really easy for that high EMF, electromotive force, to cause interference inside of this chip and screw us up and make the car stutter and give it drivability trouble and lose power. But there's a phenomena in printed circuit layout known as ground boundaries, and you can set up ground boundaries. There's a foil that you don't see that runs along parallel to this that's grounded, and it's a quiet ground, and it protects the rest of the foil on the other side of the river from all that electronic noise. It's a black art. It had to do it with trial and error. I got my customer really frustrated paying for new printed circuit board designs. Every time we're getting a little bit better until we got clean as a whistle. So this one is clean as a whistle. So I don't want to change it. Nobody's going to talk me into changing it because we start that all over again.
How many layers?
It's only 2. It's a real simple board. I made a pet containment system several years ago that had 12-layer boards. 12 layers. You can't work on the inside layers. You know, they all got to be right. That's a big headache, but the whole thing was the size of a postage stamp.
Good question.
Oh, excuse me.
So I'm assuming Chrysler did not have a design patent for that box. Is that why you were able to make it identical?
Chrysler is negotiating with us right now. They want to buy it. They evidently don't have a design patent. I did a patent search. I didn't run across any.
It'd be expired.
It would be expired anyway, yeah. We patented it, and what we patented, amazingly enough, was that it looks like a Chrysler box. and we had to fight the patent office. Is we don't give patents for that kind of stuff. I said, well, I told them it's really, really important to my client that not somebody doesn't come along and knock us off. There's a whole bunch of people that make aftermarket stuff that doesn't look at all like Chrysler, we spent a lot of extra time and care making it look just like Chrysler. Oh, well, we'll think about it. Whoop, the mail comes and there's our patent. So it is. It is
Design
possible.
patent.
What's that?
Design patent.
No, that was a device patent that included claims about packaging. Any other questions? Anybody in here own a vintage Mopar muscle car? Want to be a test driver?
How come it's only works on Chrysler?
Well, because everybody under the hood has a proprietary different system. It's very similar to Ford's, so Ford will be next. Because all we did, but Ford has a cast aluminum box. So we got to make a cast aluminum box to make it look like Ford. The printed circuit board doesn't have that big connector as a Chrysler connector, that'll go away. But probably all the rest of it, the circuitry and the software, will be the same. And that's the same as American Motors. Then there's General Motors. General Motors is a monster market, but they make in the cars that have distributors. And this goes back to the cars that have distributors. Cars today don't have distributors. Those of you who are auto mechanics or auto-minded, they have spark plugs, it's called COP, coil on plug. Spark plugs down in the hole, and the coil on top of that, and then there's a little wire from the microprocessor that makes the spark. And so you don't have any high voltage wiring under the hood. That's a way better design. And that happened about 2000, maybe 2006, maybe 20, I don't know exactly what year across the board. General Motors is the only one I know about. I have a 2010, it's got coil-on plug in it. But anyway, the method of sensing when to make a spark is magnetic in Chrysler. It's optical in some of the others. It's magnetic in Ford also. So Ford and the Chrysler technologically are pretty closely matched, but they're entirely different in terms of look. So we have to retool. And it's a pretty good sized market too. So that's the next market. So we'll take as much of the CAD design as we can from what we've done and just spin another version. And that's another great big advantage for CAD. You don't start from scratch again. Not when you're making something with a lot of intellectual property saved from the previous model.
That's basically a revision.
Yes.
You're just starting over with a new version.